Hello, hello. Welcome to the Swarms 8.5.0 workshop. Today, we're going to be going over some of the latest updates and improvements to Swarms. Uh, let's get this started. Okay, so yesterday or 2 days ago, we released Swarms 8.5.0. This is one of our latest updates. We introduced an entirely new multi-agent orchestration mechanism called social algorithms. We also improved a lot of our existing structures like AOP and MOA and various other orchestration mechanisms. And we also, of course, fixed a lot of bugs. And today I'm going to be showing you and like going over the code step by step and showing you all the improvements live. So yeah, we're going to be following this blog that we published a couple days ago. So if you want to follow like the code examples and things like that, all the code and everything that I'm going to be showing you today is going to be found in this blog article. So yeah, we could link that below. So, but all in all, this new update is extremely important because we're starting to go from testing locally, and with AOP now we can deploy things very easily into production. So it's very very important that we keep improving the infrastructure so more and more builders can deploy into production. So yeah, let's get started here. So the newest feature that we introduced in the latest updates is called social algorithms. And so basically, what this does is it enables you to custom define, um, essentially enables you to custom define special ways of enabling agents to communicate with each other. So you can essentially define how the agents will communicate with each other. And here we define a function. So it's a function, it takes in a list of agents and it also takes in a task. And so the task is going to be the main entry point. And so within this function, we define here how the agents are essentially communicating with each other. And so, each agent works on the task independently. Each agent reviews another agent's work, circular review. And then here we define the agents. And then here we have the social algorithm itself. It's pretty simple to initialize. You just give it name, description, agents, and the actual social algorithm that you're using, which is this function. So yeah, we basically just define the social function, and then we create our agents. You could put, you could essentially specialize your agents to do whatever you want. You can give them tools. You could give them MCP servers. You could even use external agents like Claude Code or any other agents that are accessible via an API. So yeah, basically, like it enables you to upload custom social algorithms as a callable. You can define pretty complicated and complex communication patterns depending on your needs. So I would say like most business applications are going to have different communication requirements. So you could choose like essentially how the agents will communicate depending on the problem that you're trying to get them to solve. So you could choose how the agents interact with each other, and it's very flexible and modular. So you could swap out different functions and use them as you wish. And the docs for this are on the site. You could check out the full docs here in the reference documentation section. So yeah, I'm going to be going over the code examples now, so you could see like how it works. So this is the code. Let me just make this simpler. So this is the code that I was just showing you. We can now run this, and we have a folder. If you go to the examples folder and you go to multi-agents, you could find a bunch of different social algorithms. There's like 10, or actually maybe 10, more than 10. And they're all different. Like they all showcase like what you could do with the social algorithm. So you could make it adaptive. You can make like an auction market type of multi-agent system. You could have a consensus. You can have hierarchical decision making. You can do iterative refinement, and you could do like multi-stage pipeline, and there's like a bunch of other examples. But I'm gonna run this now so you can see like how it works. Actually, I'm gonna swap out the model that we're using, and we're gonna use Haiku, because Haiku is nice. I like Haiku a lot. So we're just gonna swap these models. We're just gonna use a bunch of Haiku agents, and we can customize this task. So we could be like, what are the best gold ETFs? And yeah, so as I mentioned before, you customize the agents as much as you want. I'm just gonna run this here. So we have name, description, agents. You give it a list of agents. Then we have the function, and then we could also add verbose for logging. So I'm gonna run this, and we'll see that the agents working with each other. Oh, I see. Running into an issue. Let's turn off verbose for now. I see. One moment. Where is this coming from? Very interesting. Where is this? I think this might be the issue. Okay, now we're having another problem, which is that so on the new Haiku models, you cannot have top P, so you need to set top P to none. I think that's something reasoning related, but you can definitely just turn that off. So, okay, now it'll execute. So SPDR Gold Shares, iShares GoTrust, Invesco, QQQ, Gold Miners ETF, VanEck Gold Miners, iShares Gold Miners. And then now they are reviewing each other's work. So it says constructive feedback on analyst gold ETF analysis. The table format is easy to scan and compare. Critical issues and corrections needed. IU expense ratio listed as 0.25. Actual 10.01 10% or point 0.010%. This significantly represents cost comparison and could lead to poor investment decisions. Invesco QQ Gold Ticker listed as ONZU. The correct Invesco physically backed gold is GLDM. And yeah, so basically the agents will do work, and then the agents will all review each other's work, essentially. That's what the peer review algorithm does. And so this is pretty useful if you want like the agents to like review each other's work. And if you're not certain that their response is going to be good, you could use the peer review to first have them do the work, and then have them rate each other's work. And so I feel like this would be pretty good for like anything where you need to do research or like essentially medical related things. Like if you don't know that, like if an agent diagnoses a patient with something, you could essentially have the agents review each other's work and potentially find other potential diagnoses or research findings. So that's like one example of the social algorithms. If you want to learn more about it, you can go to the examples folder and check out the other examples that we have. Now, moving on, we have an entirely new structure that we implemented from a paper called Rethinking Mixture of Agents. Is mixing different language models beneficial? Self-MOA-seq represents an evolution beyond traditional mixture of agents architectures. And so basically, self-MOA is a new type of mixture of agents architecture that came from this paper, and it's been shown to outperform the original MOA. So this is how like you would use it. It's pretty simple. You just import it, initialize it. You can use any model. I'm probably going to use Haiku again because I like Haiku. And then you just give it a task. Say here we're describing an effective treatment for a patient with a broken rib. Yeah, we just copy this. And actually, I think I already have it here. Yeah, I already have it here. Nice. Yeah, so this is the self-MOA. We're gonna run this. I'm just gonna copy the model name because GPT-4o mini is kind of old. And yeah, so initialize model name temperature. Actually, is this gonna work? This is gonna work. Actually, I don't know if there's a setting to turn off the top piece, so probably not gonna do that now. Yeah, so we're gonna run this, and you'll see how it works. And so basically, what's gonna happen is this is essentially the architecture. So there's a proposal agent that generates number of samples for the response. Phase 2, aggregator process responses in sliding windows, prioritizing optimal outputs. And then phase 3, the process continues until a sample exhaustion or max iterations is reached. So yeah, it's probably going to run for some time, but this is essentially like an improved version of the original MOA, which we've had for a long time. It was one of the like first structures that we integrated, and this is basically like what it looks like. But yeah, so now the agents are providing multiple responses. Response 3. So it generated 4 samples. Now phase 2 will begin. So I would say this is like this is really good for like research related things. And anytime where you believe that an agent's output may not be correct the first time, but could theoretically be correct in the future, I would recommend using Self MOA. So yeah, basically we saw here it generates a bunch of samples to a given problem, then it's aggregated, and then it's summarized and simplified. So it completed in 78 seconds with one aggregation iteration. And yeah, that's pretty much it about SAFMOA. We'll probably add support so that it can process Claude models, because here we have actually I'll just do that now. So yeah, it can't use Haiku because there's no way to set the top p to 0. So now we might be able to actually run Haiku. We'll test that out, but I don't know if it'll work. Yeah, you see. Okay, now let's try. Yeah, it's very interesting because the cloud models now have, and I also think like O3 or O4 also have this problem where you basically have to set the top p to 0, otherwise it just simply does not work. So yeah, that's something to keep in mind. Now it should work with Haiku. Yeah, Haiku is Haiku 4.5 is definitely much better than GPT-4o Mini. But yeah, so we can see the responses there. And yeah, so that's about it for the Self MOA. If you'd like to learn more about it, you can go to our documentation, and you could read the docs. We have all the reference documentation for Self MOA here, so you could check that out and see how it works. And this is the aggregation. No, aggregation is starting now. And it's done. This is the aggregator. Yeah. So broken rib, emergency assessment, rapid triage to rule out life-threatening injuries, pneumothorax, hemothorax, pulmonary contusion, cardiac or organ trauma, imaging, chest X-ray, standard CT scan if high-energy trauma, multiple fractures or complications suspected. Acute stabilization protocol, supplemental oxygen if SFPO is less than 94% or respiratory distress present. Cryotherapy, ice packs, 15-20 minutes every 3 hours for the first 48 hours to reduce swelling. So yeah, if you work in healthcare, should maybe consider trying out Self MOA and see how it works. It might be very beneficial. So yeah, that's Self MOA. It's super cool. It's a really good architecture, and it's been shown to be better than the original MOA. So yeah. Okay, now on to some enhancements that we've made to the Agent Orchestration Protocol, or AOP for short. We have added a queue management system. So now, essentially, every time you send a task to an agent, you can queue up more tasks for that agent once it's finished. So it's kind of like when you use if you use Cursor, you essentially it's doing something, and then you send another task, and then it just waits until the current task is finished. So yeah, it's a basic queuing system that provides asynchronous task scheduling supports. It also provides agent workload management supports, There's also priority-based execution modes and dead letter queue for failed tasks recovery. And I'll show that to you now. You'll be able to see it. And then we also have some new health monitoring and observability utilities. So the new health check capabilities give you real-time visibility into AOP system states, so you can monitor the life cycle of agents and see if they're active or initializing or being shut down. So, and there's also a resource utilization tracking per agent, essentially through memory and CPU usage. There's task completion metrics and failure ratings as well. And there's also custom health check hooks for integration with monitoring systems. And yeah, so this is all like on the back end. You don't need to do anything to get these improvements. You just run the AOP server. So I'll quickly go over on how to do that now. So basically, you go, you import your agents, and then you also import AOP. You could also do this for simplicity. And then you would, build your agents as you wish. Here we're using Claude Sonnets. We have an analysis agent, a research agent, a writing agent, a code agent, a financial agent, and a bunch of other agents. So yeah. Here we're using Sonnet. I'm going to switch it to Haiku. So we'll do that very quickly. And yeah, so you just build your agents first. You could also give multi-agent structures to AOP. So if you wanted to give self MOA SIP, you could also give that to AOP as well. So basically, the way that you would initialize it, you could create a variable, initialize it. You can give it a server name. So right now we're just calling it my agent server. You can make it verbose. You can also give it a port, and there's like a bunch of other settings that you can give. Then we create a list of the agents, and then we add agents to the batch. So we add agents in batch to the server, and then we simply just run the server. You could also choose the transport. So here we're using streamable HTTP. And you could also do Studio. So that's also another option. And yeah, so if we just run this file, we will now have the AOP server set up, and it's currently running right now. So the AOP server is now running. All the agents are in the server, and now we can call the server. So I'm going to get this file. And this file right here is how we're going to actually execute the AOP an agent in the AOP server. And it just basically uses the raw MCP client. So you can use the raw MCP client to run an agent in the server. So this is just standard logic. We could also list the tools available. And yeah, so here we have the main function. This is the URL. This is the agent we want to call. So we want to call the research agents, and we're going to list the tools. We're going to print that out as JSON, and then we're actually going to call the agents in the second step. So there's like 2 steps here. So yeah. So if we clear this out, we could run this. And I'm going to put the other panel here so we can see the results. So here are all the tools. We have a bunch of tools. Each agent is also listed as a tool. And then here we see the responses from the server. And now we're going to call the agents with the task. And yeah, so we just got the response. This is the response from the agents, the research agents, and we'd also ask another question like, what are the latest vaccine trials coming up? The experimental drug trials coming up. So yeah, the server's still running, and we're going to call the agent again. This time with the new task. So what are the latest experimental drug trials coming up in the next 6 months? Okay. Generate categories of active research. GLP-1 receptor agonist, obesity, Alzheimer's disease therapies, cancer, immunotherapies. Haiku does not seem to have knowledge about specific trials, but I think we could change that if we gave it a tool. So yeah, that's essentially a demonstration of the AOP protocol. There's other tools as well that we can use, like discover agents. Let's see, where was this example? Let's see if we can find it. There it is. So this example just essentially prints out the agents. So we're going to run that and see if we're on the right port. Yeah, we're good. Yeah, so again, this is just MCP logic. So just like raw MCP logic. And so here we have the tool find tool by server name. We're gonna use this function. So function discover agents, and then we're going to execute a call. And then we're gonna format the agents. So here we can see all the different agents that we have in the server. So your agents can query other AOP servers, and agents can now find each other. So, which is very, very useful if you want like full autonomy. Yeah, so there's a bunch of other tools. If you'd like to learn more about AOP, then I would strongly recommend you go to our docs. It'll be all the way at the bottom. And we have a pretty extensive documentation on AOP. So you can check that out there if you want more information. And there's also a new benchmarking suite. So we benchmarked AOP to infinity and beyond, and it's pretty fast and pretty memory efficient. So if you want to run the tests, that's in the Swarms repository. And if there's anything you'd like to contribute to AOP as well, we're very, very open to contributions, and we welcome everyone to contribute as they wish. So yeah, then there's also export capabilities. So you can serialize an entire AOP configuration to JSON or even YAML. And there's also export runtime state snapshots. So yeah, we made a lot of improvements to AOP the past few weeks. So it should definitely be much more reliable and production grade as of this moment. And yeah, so next, moving on, we have optimized our UV loop integration. So we've basically, in the past, the user had an issue because they were trying to use this function, but UV loop is not supported on Windows. So we added support for WinLoop, which is the Windows equivalent of UV loop. So you can now run agents fully synchronously. So yeah, we mentioned that here as well. So let's get an example. I'm going to quit the LP server. Okay. Let's just clean up our environment. All right. Where are the examples? Run agents concurrently, UV loop. This is the one I wanted. All right, so we're gonna clean this up. Nice. Now we have one terminal. And yeah, so this is basically how to use the run agents concurrently with UV loop. We can also simplify the import like this. So it's just one line. Here we have two agents using GPT 4.1, and then we can run the those two agents asynchronously with UV loop. And yeah, here's the task. We can probably give this a better task. Let's see. What are the best new therapies for diabetes? And then now we can run this. So we're going to run this. And you'll see how it works. So UV loop is I'd say one of the better asynchronous frameworks in Python, if not the best. So this is essentially what you would use in production if you wanted to run agents fully asynchronously. So we have two agents, and they both gave us two responses. So the first one says GLP-1 receptor agonist, dual and triple incretin agonists, and yeah, there's a summary of the tables. And the second agent also gives us some of the same answers, but also some new ones, like T1D. So that's very interesting. But yeah, as you saw, it's pretty fast. And you could also choose the output type. So you can choose like if you want a list or if you want, a dictionary or things of that nature as well. So yeah, if you want to run agents asynchronously, you should definitely check out this function. But yeah, so that's that. Moving on. We didn't put it. We didn't provide a good example here, but we did enhance the mixture of agents backend. So we made it truly concurrent. We improved just like the general architecture of the structure itself. We reduced our memory footprint through streaming, and just more like error logging and things like that. So there's no changes. Nothing you need to do. Is just all happens on the back end. So yeah. Then we also improved our one of our most important utilities called run agents concurrently. So it's a function, and basically what it does is it just runs agents concurrently with the concurrent package. But now you could also have it return a dictionary, so that it'll output a dictionary where every value, where every key value has the key, which is the name of the agent, and the value is the response of the agent. So let's see. This is the example in the blog. Going to just, yeah. So this is the example I was just showing you, but in Cursor. And here we're going to change the task to essentially say what are the best energy performing ETFs. That's not a good prompt. Improve the prompt to say what are the best ETFs for energy. Yeah. So these two agents here are going to run concurrently, and they'll both give different answers. And the output will be a dictionary of the names of the agents. So that's pretty useful if you want to like fetch the name of the agents and then do something with that response. And yeah, that's about it. Pretty quick. XLE, VDE, iShares US Energy ETF. This is a good one. Similar to XLE. SPDR, S&P Oil and Gas Exploration and Production ETF, iShares Global Energy ETF, and we have pretty much the same response with a second agent. And we have a table, so we can see the expense ratios, AUM, dividend yield, top holdings, and things of that kind. And yeah, so that this is like the outputs. Here we see the name of the agents and then the response. And yeah. And so yeah, the run agents concurrently function now supports multiple output agent types with proper type safety. Generic type parameters for compile time checking, runtime type validation, support for custom output serialization formats as well. And it can also now support images. So you can essentially give the agents images and they'll analyze the image as well. Let's see. Oh, okay. So now we onto like some other improvements. There's not necessarily some code examples for this, but I'll just go over them pretty quickly. We made improvements to agent configuration. So agents now support dynamic input arguments via dictionary updates. We improved compatibility with Pydantic base models. We're adding support for a Python 3.14 free threaded version, which removes the GIL completely. And essentially makes like any code that you run now actually concurrent, because before swarms and anything in Python before 3.14, unless you were using the experimental version, was not multi-threaded at all. And that's because of the GIL lock. So the GIL lock is essentially an issue because there was only one process or one thread that could run in Python because of the GIL lock. So we're adding support for 3.14, and that's going to make your agents run really, really fast alongside all the other improvements of Python 3.14. We fixed a bunch of bugs. If you want to check out some of the bugs that we fixed, you can go to our issues section and on our GitHub, and then you could go to close and you'll see some of the agents, some of the issues that we fixed. We also improved our code quality. We removed around like 80 unused documentation files, so that was a pretty big, that was a pretty good improvement. We removed unused artifacts from the root directory, and we just cleaned up the repository as best as we could. So we deleted a bunch of other stuff as well, mostly in conversation, but we'll be building examples for that as well. We also removed docstring parser, which was a package. So we've been trying to like essentially clean up the package so you could download it faster and faster. And we deleted like 5 packages in total over the past couple of weeks. We deleted PyTorch, we deleted transformers, we deleted OpenAI, we deleted a docstring parser, and we just made like the installation process much easier to conduct. So download times might now be like 90% faster or something, and 90% faster, and also significantly smaller because we don't have PyTorch anymore. If you use PyTorch, the PyTorch download time is like I think a gigabyte just like with itself. So yeah, Swarms now is much easier to download. So yeah, and that's about it for the update. We've gone over pretty much everything, all the code, step by step. So yeah, let me see if there's any questions now. Oh wow, I don't think I was recording on Restream. Hey. Yeah, I wasn't recording on Restream. That's unfortunate. But yeah, so we're probably gonna make like another YouTube video, just showcasing again everything that we mentioned today, because I made a mistake. Actually, no, this has actually happened before. So, this happened once where it just like stopped streaming. So, but yeah, we're gonna make like individual tutorials for like all these different examples. So, the next update of Swarms is going to be very interesting. I don't know if I could say too much about it now, but we're going to be adding in some new multi-agent structures that are going to be very interesting. So, and also we're going to be continuously supporting AOP as well. So that's going to be super cool. But yeah. Oh, you recorded the stream? Rolly? Oh, that's cool. That's definitely good. I think I just had too many streaming.
I missed like the first minute of it though, but like the rest of it, I got it.
Oh, dude, that's amazing. That's good. Yeah, I think when you start streaming too much, like I think it definitely messes up because, yeah.
Oh wait, is the stream over?
No, it's not. It's not over.
Oh, okay. Wait, should I keep recording?
I think it's pretty good now.
Okay.
But I yeah, if you could send me that, that'll be pretty. That'll be
yeah, I got you.
That'll be nice.
Yeah.
I was streaming with 3 different things. So
Oh yeah, I saw.
I think that might be the issue because it'll just like trip out or something. But yeah.
But yeah, I usually record things because like when I listen to like the first time, I can't like fully understand it, so then I have to like rewatch it to like fully understand things. So
yeah. Well, thanks, man. That's nice. Well, I'll have to post that on the YouTubes. But yeah, I gotta figure out how to do this, like stream in many places at once, very easily because this has already happened like once before. So
some bad news though. My PC fan is a little bit loud, but you can still hear it, or like you can hear yourself, but there's like a little bit in the background.
oh, Is it really loud?
Let me re-listen to it. It's not like
Oh,
it's not that bad. Like you can hear yourself, but it's like subtle in the back.
I see. Well, it's we could use AI to fix that.
Yeah, yeah.
Um, but okay, so we're gonna republish the stream because my computer cannot handle all the streaming at once. But yeah. So
But yeah, I'll send it to you later.
thanks, bro. I appreciate that, man.
Wait, how should I send it to you since it's like 40 minutes?
Oh shit.
Should I just like upload it on YouTube or something?
Yeah, honestly, that would probably be the easiest thing, and then
Okay.
we'll just share that like on the socials.
Or I could like upload it and you can just download the video and then upload it yourself if you want.
All right, sounds good. All right, I gotta I gotta go back to publishing the stream, but yeah, in general, like I think the updates is one of our most important updates ever. People now definitely have a lot more flexibility,
Yeah.
and we're like the goal now is to like make it so simple to deploy agents in a production, and start getting feedback and enabling the agents to be more autonomous. So before AOP, it was like very hard to deploy agents in a production. You need to build like your own like 2,000 line file of API code, and that's just a waste of time. So now you can essentially build a server for your agent in like maybe 5 lines of code with AOP. So that's very important, and yeah, we're gonna continue like making improvements to the entire infrastructure workflow. So um, yeah,
That's pretty cool.
yeah, thanks, brother. Um, but yeah, so that's the end of the workshop for now. I'm going to find a way to republish this on places so people can see the code actually running. The entire time you're just staring at my very beautiful face instead of instead of the very beautiful code, which is much more beautiful to me. But yeah. All right, thank you guys for joining in, and stay tuned for the updated recording. So, yeah, thank you guys. Bye bye.